Good morning and welcome to today's webinar, Unlocking the Potential of AI in Sustainable Design. My name's Laura and I'm part of the Sustainability Communications team here at Click LCA, and I'm joined by Alex Kurzweil, our VP of Customer Success, so I'll pass over to him in just a moment. Before I do that, I just want to set the scene for this session today. So if anyone attending the webinar was at Future Build in March this year, you may have seen Alex's session on this very topic. This was one of the most well-attended sessions of the whole event. So it's clear to us from that, and obviously as well by the number of attendees that we have for this session today, that this is a very important topic. So here's what you can expect from today's session. I'll pass over to Alex in just a moment to introduce himself, explain what it is that we do here at Click LCA, and to kick off his presentation. You'll then have a chance to let us know if you'd like to speak to us after this event about your own projects. You'll see a poll pop up on your screen later on, so just let us know by clicking yes on that poll. And then we'll get to our Q&A. So down the right-hand side of your screen, you should see a questions panel. So at any point during the session, you can drop your questions in there, and we'll spend 10 to 15 minutes answering as many of those as we can towards the end. So without further ado, Alex, over to you.
Thanks, Laura, and hi, everybody. Thanks for making the time to join us for this webinar. So I'll introduce myself in a second. Before we get onto that, for those who don't know, a little bit about Click LCA, and then we'll dive into today's agenda. So what we do here at Click LCA, as the slide says, is we provide a sustainability platform for projects and products. What does that mean? Essentially, what we do is we provide software which covers every aspect of the value chain in the world of construction, and particularly sustainable construction. So whether you're a manufacturer creating construction products, whether you're the specifier or one of the users of those sustainable products, so an architect, an engineer, a contractor, a developer, or whether you work in one of those related fields, we provide software which allows practitioners to make low carbon design decisions right across that construction value chain. We'll, in the course of this presentation here, lots more examples which bring exactly what we do to life. So let's dive into it. I'll just introduce myself as well. So as Laura said, I'm the VP of Customer Success here at Click LCA. What that essentially means is I'm responsible for everything we do from a customer-facing point of view. Previous to this role, I've been at Click a couple of years. Prior to that, I did basically the same thing at Peak AI, which is a Manchester-based artificial intelligence company. So I kind of straddle both the worlds of sustainable design and also AI. And hopefully what we'll do in the next 45 minutes or so is bring those two worlds together and talk about some concrete examples of how AI either is or will impact on sustainable design and low carbon design. Just to build on what Laura said, if you've got questions, we will have plenty of time for Q&A at the end, so please add them in the questions section. If you've got a burning question which relates to something I'm talking about at that very moment, you can feel free to drop it in the chat. If I see it and if I get to it and if it's the right time to answer the question, then I'll do it then. If not, we'll pick it up at the end of the session when we get into the question and answer. All right, so let's move on. Just to take you through the agenda, we'll start off with some high-level principles, both about sustainability and design, but also about artificial intelligence, just to ground the content of the rest of the session. We'll talk about the fit between sustainable design and AI. We'll move then to what are the problems that actually need solving, and we hear all the time from practitioners about their pain points and their challenges. So we'll look at those, and then we'll match them to how artificial intelligence can actually solve them or could solve them in the future. And we'll give practical examples which illustrate how that's happening. And then finally, we'll round off before we move on to questions with a glimpse further into the future of how AI and sustainable design could continue their journey together, and what will the future look like for an AI and data enabled future for sustainable design. Okay, so some high level principles to get started with, and we'll start with sustainable design. I think it's helpful just to give ourselves a high level definition of what we actually mean by sustainable design. This one is taken from the UK Green Building Council. I think it's helpful in contextualizing what we're going to talk about today. So they define sustainable design as the purposeful design of buildings, places and products that minimizes harmful environmental impacts, drastically reduces carbon emissions, positively increases health, well-being, biodiversity and social value throughout their life cycles. So a wide-ranging definition, I think, of sustainable design, and one that kind of meets our purposes in terms of today's talk. So what about AI? How do we define that? I think that's a lot more difficult than the definition I've just given of sustainable design for lots of reasons, but you'd have to have been kind of living in a box for the last few years not to have been exposed to the conversations, the hype, the media narrative at times about artificial intelligence and how it's impacting what we do and our day-to-day lives. We've got this sort of perfect storm of big media personalities, tech owners of the companies which stand to gain a lot from the AI revolution we're going through. Of course, we've got kind of hype, we've got media scaremongering, we've got a lot of headlines, just endless column inches speculating about artificial intelligence and the impact that it can have on what we do and how we live. So what that does is it just generates a massive amount of noise. And I think as practitioners and people who are looking to actually use AI in a positive and helpful way in our working lives, it can actually make it quite hard to focus on the specifics and the areas where we can actually benefit from using the power of AI, which is clear and which is obvious. So just before we get into some of those specifics around AI and its potential impact on sustainable design, I think it's useful just to contextualize artificial intelligence from a chronological point of view. We're on a bit of a journey with AI, and what I'll do is I'll take us through 4 stages in the evolution of artificial intelligence. This isn't a detailed kind of history of AI or anything like that. It's just to contextualize the points we're going to talk about in the next half an hour or so. So let's start with point AI solutions. And what I mean by point AI solutions is software solutions, algorithms, AI models, which are typically built around a specific business activity or process. So there's many, many examples we could use. I pulled out 3 here. Examples very familiar from my previous role, but the 3 examples I pulled out are inventory optimization, recommenders, and quote price optimization. So these are very specific business processes. They're processes which are data rich. They're processes which have a high degree of historical data, which is really important when you're building and training algorithms. And in each of these areas, you can take hundreds, thousands, tens of thousands of previous decisions that were made or activities that were taken, which have a data point associated with them. And you can use those to build and train an algorithm, which is then able to predict what would be the best course of action in the future. And typically these take the form of decision support algorithms. So if you take the first example, inventory optimization, an algorithm could be built which has been trained on hundreds or even millions of previous inventory decisions, and it's able to suggest the right balance of stock and, for example, pricing to balance inventory and optimize working capital. So this isn't specific to sustainable design at all, but this is the kind of decision which is in use across thousands of businesses globally. And by building an algorithm, you can optimize decision making at scale in a way that wouldn't be possible with a human. And there's lots and lots of examples of point AI solutions which are in place now. There's lots of companies which specialize in this work. So that's kind of, if we go back to pre-generative AI and large language models, this was where a lot of the commercial conversation around artificial intelligence was living at the time. If we then move forward to kind of the dawn of ChatGPT, we get to generative AI and large language models. And this, I would hazard a guess, this would be many people's introduction to commercially available AI. If we did a straw poll of the people on this call, how do you use AI in your day-to-day life? My gut feel is that the vast majority of people would be doing this. They would be using large language models, whether it's ChatGPT, whether it's Claude, whether it's Gemini, to do some of the things listed on the right. So content creation, helping with productivity in the apps that you use, and co-pilots as well. And that's, to a certain extent, that's where we're at the moment. We have point AI solutions operating on specific business processes. We have generative AI, which has opened up the capabilities of artificial intelligence to millions and millions of people globally, and which is having a daily impact on productivity, in terms of many of the use cases which we'll all be familiar with and many people will use. Let's move forward then to the next point, which is agentic AI. And this is, I guess, the current frontier, many people would say, in terms of commercial application of AI. And as the name suggests, agentic AI it's AI agents or AI robots that are able to learn and apply that learning to specific tasks and specific workflows. So in some ways, they combine the previous 2 points, and a business is able to deploy AI agents to complete specific tasks, specific activities. So examples would be customer service agents that go beyond just kind of chatbots, but are able to actually process tasks. So they would own a conversation with a customer who wants a particular thing to be done, and then the AI agent or bot would actually complete that activity from end to end. So it's taking many of the principles of generative AI and large language models, but it's actually making them more action focused, and it's driving real commercial benefits for the companies that are starting to deploy them. And there are many commercial AI companies which are focused entirely on deploying AI agents and agentic AI to help companies work in a more efficient, more scalable, and ultimately, I guess, more profitable way. So that's kind of where we're at and where we're going at the moment. And then I guess in the future, and this is a bit of a catch-all term, but end-to-end AI, and I don't necessarily mean here artificial general intelligence, which gets talked about a lot as well. But ultimately, we will get to a point where full complex end-to-end workflows are able to be run by AI. So it's building on the agentic AI principles we talked about before, but it's adding a layer of intelligence and a layer of additional or enhanced processing ability to complete more complex and more open-ended goals. And I'm conscious that's a slightly vague definition. As we move beyond agentic AI into the more generalized end-to-end AI, there's a few options as to how that ends up, and we'll see. I don't want to spend too much more time kind of speculating on the future of AI commercially. The focus of this presentation and this webinar will not be on the end-to-end AI, because that's going to be some way in the future. It'll be on the previous points. So those are some high-level, I guess, guiding principles or contextual facts, which hopefully will help to ground the rest of the presentation that we're about to move into. And it's just I just thought I'd put this in. This is a quote that I like. So it's from Andrew Agnost at Autodesk, as the CEO, a recent keynote he gave, and he said, "The great sorting out of the good from the bad is just beginning." I think it's an illustrative quote. I think we're kind of there. There's a lot of noise. There's a lot of hype. There are many, many companies and use cases built around AI. some of which will prove to be enduring and value creating and indispensable in the workflows of the future. Many, or the majority of which, will fall by the wayside. And we're just at the beginning of that journey. And who knows which things will prove to be indispensable and which things won't. So yeah, we're still sorting out the good from the bad. So as a final principle, this may be an oversimplification, but I basically think of AI as helping businesses in two ways. It either drives efficiency, so it allows you to do tasks quicker or at a greater scale, or it improves quality. So it allows the outputs of the process or the thing that you're doing to be done better. And frequently it does both, right? So if you're able to do something with fewer resources or in less time, and the outputs that you create are of a higher quality, you add those two things together and you will create business value. And the sweet spot of AI is where we're able to find processes or parts of a business where efficiency or scalability and quality can be combined to create more value. There are many, many examples where this isn't the case. And there are plenty of examples where AI doesn't do this yet, and where it makes more sense for humans to continue to do this work because they can either do it to a higher quality or they can do it more efficiently. So part of the sweet spot or the goal is finding processes where AI can genuinely create value for businesses or users. And typically it's through efficiency or quality or the combination of both. Final point. So AI and sustainable design, why do they work well together? There's a few aspects to this. The first one, and we know this as well as anyone, I think, at Click LCA, sustainable design as a field, particularly life cycle assessment, is highly data driven. In order to make good sustainable design decisions, much of that has to be based on data. So almost everything we do at Click LCA is driven by high volumes of data and the most accurate data we can get. The same is true of AI. In order to build and operate effective AI models and AI-based systems, you need to have high degrees of good quality, accurate data. So there's a natural synergy there. The second point is sustainable design. We have a lot of data, not just at Click LCA, but comparable and similar practitioners. There are hundreds, thousands, millions of design decisions being made across vast numbers of projects globally. All of those are generating data, which is able to be captured and used to, as we'll see in this session, to train AI models which can enhance decisions going forward. So both processes are data driven, but actually both benefit from there being lots of data available. Next, so sustainable design is highly workflow and process based. Many of you practitioners of sustainable design and sustainable construction obviously will know this. Large parts of this world are prescribed with specific workflows or processes. AI works really well in this environment. When we talked about the journey of AI earlier on, particularly those point-to-point AI solutions, AI can be really good at optimizing a particular workflow, a particular process, or a particular part of a workflow or process. And construction is divided into those processes, whether it's the REBA stages, whether it's comparable stages elsewhere. Sustainable design lends itself well to being optimized by AI because we can focus on specific parts of this segmented workflow. And finally, a point that, again, I think will be familiar to many on this call. The reality is that parts of design are still pretty manual and pretty tedious, particularly when it comes to life cycle assessments or the creation of EPDs. Whether it's mapping your project's specific data to a sustainable database, there's lots of other examples. These are these can be tedious tasks. And where we can use AI to automate or make quicker these tedious tasks, we should. And we can, and that's what we're doing at Click LCA, along with with many similar organisations. So those are some principles. Let's turn our attention to where we are now. And as I said at the start, we'll look at some of the specific pain points that practitioners of sustainable design are currently experiencing in their day-to-day lives. And these are things that we hear from customers all the time. And then we'll map those to ways in which AI can, is, or will help to alleviate or improve those pain points. So I'll run through these pretty quickly because we'll go through them in more detail as we walk through the examples. Number one, lack of quality data. So the number one pain point we hear, people always want more data and better data in order to be able to make data-driven design decisions. Linked to that, number two is the cost and also the time of creating EPDs. So EPDs are one of those units of data which would address pain point number one, but it's expensive and time consuming to create EPDs. So that's a pain point that people would like solved. The next one I mentioned briefly earlier is data mapping. So you have a design, you want to create a life cycle assessment. You need to be able to map the data points in your Revit model or another BIM model or your bill of materials in Excel. You need to be able to map those data points to the carbon factor database in a tool like Click LCA. People would like that to be easier and less time consuming. So anything we can do to help with that pain point would be great. Linked to that, there are other parts of the process which are still manual and labor intensive. People would love it if the process of creating an EPD or creating a product or building LCA could be made less manual, less labor intensive, and made more streamlined. Another thing we hear quite a lot is around early stage design optioneering. So massive benefits to making sustainable design decisions really early in the design life cycle. People would love the features of people would love there to be more options for how to do that in a quick and painless way, basically, because the impact you can have early in the life cycle is huge, and people would like more options, more features that allow them to do that quickly and easily. And then final point, this is more of a general pain point, but people feel that sustainable design still doesn't feel embedded into the wider design process. It still feels like something you bolt on. So as part of your project, you do a life cycle assessment because you need to do one, and you kind of bolt it on to the main process. It's not embedded. This is a theme we'll return to again as we look further forward into the future. But people would like a greater degree of integration between the sustainability aspects of what they do and the kind of day-to-day bread and butter aspects of what they do. Okay, so we'll start talking about generative AI, and this is an area where, clearly, given the advances in recent years with large language models and generative AI, there are options to significantly enhance the way people can use software to do lifecycle assessments. So this is a concept many will be familiar with, and it shows our ability to impact or our ability to have an impact based on the stage at which we make decisions. So if this is a simplified model of design stages, so from kind of high level strategy through to actually building, there is a trade-off between the degree of precision with which we can operate. So at the strategy stage or the concept design stage, we don't know the answer to many of the questions we asked. We don't have detailed data points. However, design decisions which we make early on are able to have a significant impact in a way that, as we move to design and obviously into build, the ability to impact embodied carbon outputs is much, much lower. So with that in mind, early stage design optioneering is the key to having high degrees of impact based on the graph we just looked at. So anything we can do at this early stage to allow effective optioneering the better. And as I said, this is a pain point which, it's not a pain point, but it's something which we hear regularly from practitioners. We would love a richer set of features at the really early stages to do quick optioneering. Luckily, generative AI is perfect for these kinds of activities, and this is something which we're working really hard on at the moment, and are looking to bring to the table, and are starting to introduce in beta now. And what it basically does is, based on a high-level series of design inputs, we can rapidly generate multiple design options. We can generate hundreds, or the model that we have generates hundreds and then suggests the top handful, just to stop it from being overwhelming. And we can quickly and simply compare the predicted whole life carbon impact of AI generated options. So what it basically means is that in a short amount of time, you can spin up a series of different design options for effective, informed design discussions with clients or with other interested parties. And you can quickly think in terms of whole life carbon impact without needing to go to anything like the level of detail you would need to go to do an actual LCA. Because at this early stage, you don't have the data to do that. You probably don't have the time to do that. You may not have even won the work yet. So this is an area of focus for us at Click LCA, because we recognize that by being able to generate options quickly, but with accurate, reliable carbon data attached to them, it really unlocks the ability to have those early stage conversations with clients, with other interested stakeholders about the different design options that you have before you move into more detailed specifications. And of course, the decisions you make or the models that you generate here can then be ported into the more detailed kind of full life cycle assessments, which take place further down the line as more data becomes available. So that's one example, and I think many would recognize that early stage optioneering is helpful, it's vital, it's an area where we can have a lot of impact, and it's a good way to get started. But as many know, like, full life cycle assessment is built on data in detail, which brings us to our next pain point. And this is the number one pain point, as I said earlier, certainly for life cycle assessment practitioners that we speak to. So the screenshot on the right is Materials Compass. This is our new kind of public-facing materials database. It's the same database which you can access in the full Click LCA software, but it's just viewed and accessed and explored in a slightly different way. So this is, we think, the largest database of its kind available. It contains 300,000 plus pieces of carbon factor information and materials. But we still hear from practitioners that lack of a reliable data and the lack of extensive enough data sets continues to be the number one pain point. So people want more data. They want high quality third-party verified data, because it's only with that wide range of data that you're actually able to make fully informed, accurate, sustainable low carbon design decisions when creating LCAs. So, I mean, it's a bit of a sort of generalization, but if we say that more accurate, reliable data means more EPDs, and there are obviously many other types of sustainability data and kind of certification, but let's just assume that we're talking about EPDs for now, environmental product declarations. This brings us to the next pain point, which is we need more EPDs, but for manufacturers whose job it is to create EPDs, the number one pain point we hear from them is the cost and complexity of creating EPDs. You know, many manufacturers feel that although the regulatory and the market demands for EPDs are obvious, the time it takes to create them, the expertise needed, the training, the cost of verification, the complexity of doing so, these are all barriers which stand in the way of creating more EPDs and giving specifiers the data points which they crave. So on both sides of that ledger, we have a problem. we have people who are craving more data so that they can create more accurate life cycle assessments. We have manufacturers who want to give them more data, but it costs money, it's complex, and it's an investment of resource which many manufacturers struggle to justify. There are two ways of creating those EPDs essentially at the moment. You can either do it yourself with EPD generation software and then get those EPDs third-party verified by a program operator, or you can outsource it to consultants and pay consultants to do it. Both are viable options, but both have drawbacks. If you do it yourself, you need to find someone who can learn how to do it, which takes time and effort and money and training. If you get consultants to do it, it's expensive, right? Like it costs a significant amount of money per EPD. So if you have a lot of products, each of which needs an EPD, and you want full third-party verified EPDs for them, there's an impact. So, problem statement. Manufacturers need to be able to create and verify EPDs quicker and cheaper, but with no loss of quality. And that last bit's critical. Third-party verified EPDs are reliable and trustworthy because they're verified independently by third-party experts. And so we have to be able to continue to maintain that quality so that we can continue to maintain reliability and trust in the system. But we need to be able to create EPDs more quickly and more cheaply so that manufacturers can create them and so that LCA practitioners are able to get the data that they need. So AI can help with this. We have to be careful, but there are ways in which AI and automation can help with the EPD creation and verification process. So the creation and verification of EPDs happens thousands and thousands of times each year. Our customers create many EPDs using Click LCA's EPD generators. There are many, many other customers using different systems to do the same thing. The point is it's a repeatable process using the rules as defined by program operators. And so that makes it actually perfect for training algorithms and for being assisted and aided by artificial intelligence. So there are various ways this can happen, but in summary or in simple terms, AI models can help to quickly or instantaneously flag mistakes and check fields. So when you're, as a practitioner, creating an EPD using EPD generation software, such as Click LCA, if there is a way of identifying areas where mistakes are typically made, then by identifying them at the time and flagging them to the people creating the EPDs, the idea is we should be able to drive the quality of those EPDs up by saying, this is an area where verifiers have typically found mistakes more often than anywhere else. So you might want to pay attention to, your biogenic carbon outputs in this particular model. For example, there's lots of examples. So it's this principle of training models on previous behavior and then using the outputs of those models to identify where there could be an error or where something doesn't look right. So what does this mean from a verification point of view? Well, EPD verification has historically been it's been a lengthy process. In some cases up to 6 months to get EPDs third-party verified. From end to end, gathering data and creating an EPD, finding a program operator, submitting your EPD to be verified in accordance with the program operator in that area, potentially multiple rounds of verification via manual back and forths, emails, spreadsheets. And then finally, the EPD is third-party verified and can be published and used by practitioners. With AI built into the workflow at various stages in both the generation and also the verification processes, used either by an EPD generator like Click LCA or a program operator, or used by verifiers themselves, we can significantly improve or increase the speed at which EPDs can be created and then verified. Let's move on. The next pain point, and this is the one that I think is the most important, is the issue of data. So data is the is around actually mapping, identifying, and finding materials as part of your life cycle assessment. So if I just walk through this slide, whole life carbon reduction needs quality data. The creation of life cycle assessments needs quality data. And there are two sides to this process. So within LCA software, like Click LCA, there is a large database of materials with associated carbon factors. We need to be able to map those materials to the materials which are specified in a particular design, so that we can then play about with alternative design options, and we can create an LCA which should decrease the whole life carbon of a particular design. Right now, there are two ways of doing that. You can either import from a particular Revit model, bill of materials, etc., or you can select that data manually within the software itself. And if we focus on the import option, it can be time consuming, it can be tedious, and it can also be error prone. So there is significant room for improvement in this process. And one area that we're looking at to improve this is around artificial intelligence enhanced import mapping. So whereas previously a lot of the mapping from a bill of materials or a Revit model was manual. You had to specify the mapping of different fields to fields within Click LCA. The idea with AI powered mapping is that is done automatically. So you can basically drag and drop an input file, and AI, having been trained on thousands of previous similar mappings, is able to map materials in the Click LCA database with the named materials in your own file. And that should make life a lot easier for practitioners, and it should significantly reduce this pain point, which is something that we hear about quite often. It's probably worth saying this has been a bit of a journey for Click. We've had a few hiccups along the way, and one of the things you find with AI, like you train a model based on all of the data that you have, there are times when it doesn't work. And this, just for us, this has been a bit of a journey. We've had examples of times where the AI mapping hasn't worked as well as we would have liked, and we've had to rely on the consistent feedback from people who've used it to tell us when the mapping doesn't work. And we've had to retrain the model. We've had to add some guardrails to ensure that we eliminate those mistakes. So it's been a journey for us as well. But the principle is clear. This is mapping your model to an LCA, a Click LCA database, is something that needs to happen in most projects. And so if we can fix this, and if we can enhance and make more easy this process, it should make practitioners' lives much, much easier. And that's the goal we've set ourselves. So briefly, I won't go into too much detail, but basically the way this actually works is that natural language models, they use the names in the model that you import, they match them to the names in our database in an intelligent way, and they return the best mapping. There is a hierarchy as well, so it doesn't immediately default to AI mappings. It will use any previously stored mappings if you have previous mapping history. So there's ways in which it uses the AI, and it doesn't default to it, but when it needs to, it will rely on the AI to hopefully enhance the mapping experience and save time. Let's move on. So this is another kind of related one, and the idea here is it's just adding the material search assistant is just adding a more human interface to help users find the materials that they need from our, as I said, a database with 300,000 data points in can be hard to navigate. So by using natural language search terms, find me low carbon concrete from the UK. I'm looking for air source heat pumps close to my project in Copenhagen. Should bring a more kind of human way to find the materials that you need. Again, won't say too much more about this. It's a concept that I think is pretty familiar, and should be a way of reducing the tedium that can be there in trying to find the materials that you need. General principle, I love this quote, so I dropped it in. So I want AI to do my laundry and dishes so that I can do art and writing, not for AI to do my art and writing so that I can do my laundry and dishes. The principle here is simple. We're trying to remove the things which are painful and tedious from the process so that you can focus on actually finding designs which are sustainable and lower carbon. So spending less time with fixing import mappings and more time actually thinking about and exploring which materials are going to yield the greatest outputs in terms of sustainability. So I think we're trying to do the laundry and dishes of life cycle assessment so that you can do the art and the writing, the fun bits, basically. So you're doing your life cycle assessment. How do you know if the results are any good or not? And this brings us to the plausibility checker. And very simply, this is a way of benchmarking the outputs of your life cycle assessment with an AI-generated benchmark from thousands and thousands of similar or previous projects. So the algorithm is trained on historical data from real-world projects, and it generates a benchmark which tells you whether your outputs look about right or not. So it doesn't tell you if the results are right or wrong, but it tells you if they're plausible, and it just alerts you to any areas that look suspicious or look like they might need checking. So it's just another way of removing a little pain point, a little kind of speed bump in the process. I'm conscious of time. I'm actually going to move beyond this quite quickly. So this is a recent addition to our suite of toolings, and it's an early stage design tool. It's focused on microclimate simulation and thermal comfort, and it's a product we recently launched called EnviMet, which allows users to make design decisions which will improve the livability of urban spaces. So here we can see an example of an urban space and many of the things which impact the thermal comfort of people who will be using that space. If we move to the next image, we can see a design or an environment which has been optimized in many ways through natural design decisions to make it more thermally comfortable and more livable. So trees play a big part in this. Water can have a significant cooling effect on an urban landscape. Using light and permeable surfaces, all of these things reduce the ambient heat of an area and make it more livable, sometimes by very significant amounts, which reduce the need for artificial cooling, particularly in heat-stressed areas. So by building these, by making these early-stage design decisions, we can significantly reduce the need for artificial energy-intensive cooling methods. And in order to do that, we need to be able to simulate the impacts of these design decisions, and that's what our microclimate simulators do. So it's a lengthy and laborious process at times at the moment, and there are various ways in which AI can help to optimize that process. So the data demands of microclimate simulation are large. The data isn't always where it needs to be. And what we can do and what we're experimenting with at the moment is using AI to augment the data that we need to conduct microclimate simulations, basically filling the gaps in our data sets so that they don't cause a problem when we're simulating the impact of microclimate of particular design decisions. So that was a kind of whistle-stop tour of 5 or 6 specific examples, particularly in the areas of EPD creation and building LCA or infrastructure LCA as well, where in the real world now, AI and data are helping us to optimize things and helping us, hopefully, to help practitioners have a more kind of pain-free life cycle assessment experience. So it's just, as I said, it's about doing the laundry and the dishes so that there's more time available to do the art and writing in the context of life cycle assessment. There's a few watch outs, inevitably. AI. we have when we're talking about AI, we always have to talk about the risks. So I'm just going to turn to that now, and then we'll look a bit further ahead at kind of some predictions for what the future is likely to look like or could look like for sustainable design. So we spent most of the time talking about opportunities. When I think about the risks that AI poses, both generally, but also for sustainable design, I think there's two buckets. There's practical and manageable, there's scary and existential. So practical and manageable, model explainability is a big one. Black box syndrome. People often don't understand how AI models work, and often the people deploying the models don't understand how they work because they're trained on thousands, hundreds of thousands, or millions of data points. So there is a challenge around explainability as to why models are giving specific outputs. My kind of guidance and my learning from painful experience is it's not generally a good idea to try and explain a specific output or result in terms of how the algorithm is operating, because that's just not how AI models work. You know, they work at scale based on thousands of data points. So it's better to stick to how the models are designed, the guiding principles for how the outputs are created, and try and locate any specific aberrations or anomalies in that context. There's concerns around bias or loss of control. And then the final one is a kind of general one, particularly on generative AI, which is around ownership and IP. You know, if these are models which are trained on public data, what do we do about IP? What do we do about ownership? And this is not specific to sustainable design. I mean, at Click LCA at the moment, our AI is pretty much entirely trained on data which we own and which is restricted to our platform. So it's less of an issue for us at the moment, but it is certainly something to be aware of in a wider context. If we move to scary and existential, there are these are general, I think, issues and risks with AI that we'll all be familiar with from the narrative that dominates at the moment. So loss of creativity, commoditization of design. Where does this end? You know, like design is inherently a creative process. So by adding too much AI to that process, do we run the risk that we make it commoditized? And finally, of course, what does this do to jobs? I think if we just move forward, again, I think this is a good quote. AI won't take your job. It's somebody using AI that will. This was at the World Economic Forum Summit in Davos. And it's a good quote because I think what this shows is that the key here is to remain AI literate and to keep abreast of how AI can help you do your job better, rather than necessarily worrying that it's going to take your job, using it as a tool and using it to enhance your productivity and enrich the processes which you have to do as part of your day-to-day life. That's kind of the best advice I can give at this point. So quickly turning ahead to the future, I think two predictions. The first one, and this is not, you don't have to be a genius to predict this, but AI enhancements will continue to gather pace. Like this isn't going to slow down. Jensen Huang, picture at the top from NVIDIA, talks about hyper Moore's law. Many people will be familiar with Moore's law relating to semiconductors and the pace of technological progress. Hyper Moore's law is basically saying that AI is going to kind of make that progress more or even exponential. So hyper Moore's law combined with just more projects, more data, and more of a groundswell of input material to train models on, and then just better AI models, constantly better, more sophisticated algorithms and models are being developed all the time. If you just add those things together, it's clear, I think, that the pace of the AI revolution is going to continue. And ultimately where that ends is something like end-to-end AI-powered sustainable design, which is kind of a general term. But we'll see what that means in a couple of slides. The next prediction is just further integration. So I talked about a pain point earlier, which is it doesn't feel like design is embedded yet. It feels like a bolt-on. I think the journey we're on is that, certainly the journey we think we're on at Click LCA is for sustainable design workflows to just be almost indistinguishable from kind of standard building, construction, product design workflows as we know them. So they cease to be kind of bolt-ons to processes. They just become fully embedded in the mainstream process from a data point of view, a tooling point of view, a process point of view. Sustainability is just built in at every stage of that design process. So what does that actually mean? I'll just finish with a statement. So in the future, AI will support or own the hundreds of human-led decisions that make up every stage of the design process. So crucially, AI will support, not own, but may own the hundreds of human-led decisions that make up every stage of the design process. It will be accessible via natural language. And there will be no such thing as sustainable design. I'm happy to answer questions on what I mean by that. I'll leave it hanging. So I'm going to leave it there. Thank you very much for listening. I hope that was useful and enjoyable. Happy to talk to anyone who wants to answer any questions at this point. Laura, over to you.
Yeah, brilliant. Thanks, Alex. We do have some questions. Just quickly, you will see a poll pop up on your screen now. If you do want to book some time with one of our carbon experts to talk about your projects or products, please do answer there. I'm going to get to the questions, Alex. We have had some come through, so I'm going to start at the beginning. If I wanted to create my own large language model, how would I go about it whilst also ensuring my data is secure? A cloud-based software is safe to use?
If you wanted to create your own large language model, I'm actually, so Cassian, I'm not sure I totally understand the question. So maybe you could answer. If you mean, I don't know if you mean building your own large language model, or whether you just mean using the existing large language models, ChatGPT, Claude, etc., more effectively. If it's the latter, there's a whole literature around how to optimize your prompt engineering and so on, which can help to use large language models in a more effective way. Are cloud-based softwares safe to use? Again, whether you mean cloud-based softwares, cloud-based large language models, such as the one I mentioned before, I think like there's an element of safety and scale. I mean, there's millions and millions of users of those at the moment. I use them pretty regularly. But I don't know exactly what you mean by creating your own large language model, or whether you mean specifically to sustainable design. Maybe just drop that in the chat and I'll try and answer the question a little bit better if you can be a bit more specific.
Yeah, so we have another question here. How do you compare AI-generated LCA results with non-AI generated results? How can you be sure what the truth is of the declared environmental data?
That's an excellent question, Arjun. Thank you. So I think it depends. Again, it depends what you mean by AI-generated LCA results. So if you're talking about our LCA software, we do not generate LCA results with AI. What we do is we generate benchmarks which allow you to make an assessment of plausibility of your outputs. So it's not an AI generated LCA. If you've created a life cycle assessment and you want to quickly check whether that looks like a reasonable result and whether it's plausible, what we do is we create AI generated benchmarks based on, pretty much the full history of projects which have been generated using our software, which will give you a range. It's something we can demonstrate to you if you're interested, actually, but it will give you a range and it will tell you if your results are outside that plausible range. So it allows you then to just identify where there could be an issue and take action.
Okay, next we have a question from Yana. AI-powered import still depends on the quality of the Revit model. Most of the Revit models we work on are super basic until later REBA stages. At that point, the influence to lower carbon of the design is minimal. Any suggestion how AI can assist with this pain point?
Yeah, it's a trade. Well, it relates to that trade-off we talked about earlier, and I get that some of those models are going to have pretty low levels of detail. And the input does depend on the quality of the Revit model. So there's not an easy answer for this. Like we can't make your Revit model more detailed or better. The mapping is just designed to save time and make the experience hopefully better, regardless of how basic your Revit model is. When it comes to actually mapping materials specified in that early stage Revit model with what's in the database, if it's really early stage and you just don't have that degree of detail, the other option is to use something like Carbon Designer 3D for really early stage optioneering. But again, you're losing another level of detail there. So you put your finger, Jana, on the trade-off we have between early stage design decision making, the amount of data that's available at that point, and the stage that you're at. So there is a trade-off there. There are potential, in terms of AI helping with that pain point, there are options, you know, outside of what we do at OneClick. I would encourage you to experiment with whether generative AI can help you to come up with builds of materials or lists of materials, even at the early stage, based on the prompts you give it, to help fill some of those gaps in the specification that you have.
Brilliant, thank you. We just have a couple of minutes left. I think we can try and do the final maybe 3 questions. So question here, why do you think there would not be any sustainable design? Do you believe it will be normalized into the workflow so much that there would be no need for a distinction of it?
Yeah, that's exactly it. So the reason I ended with that is obvious. I hope obviously not because I don't think sustainability will be important in design, but it's more just to make the point that the fact that we talk about sustainable design and design, I think, highlights the fact that it's still not fully embedded. So I would love it if there was a point where, rather than sustainable design just has sustainability built in terms of the material choices that we make, in terms of the processes, in terms of people's level of knowledge, in terms of the maturity of the decision making, so that sustainability isn't a kind of a luxury or something that we do if we've got the time or the budget for, or our stakeholders want it. It's just a thing that's built in naturally to the design process. So that was why I wrote that.
Okay, brilliant. 2 final questions. So embodied carbon is also a function of structured design. How AI can help in this depends on soil type, earthquake responsive design. How is this addressed in early design optimization?
We've got some good questions here. So you're Abhishek, you're correct. And again, I don't want to, I'm sorry if I feel like I'm just making this point multiple times. There is an inevitable trade-off between amount of data and detail and degree of certainty that you have in the early stages of design, and the amount of sophistication or sort of specificity that you can build into the models. So the simple answer is that from a one-click LCA point of view, in the early design optimization that I talked about, so when we're generatively creating early stage design options, the reality is we're not really considering kind of earthquake responsive design. We're not really considering soil type. That's not built into our model. So obviously there are options to work around that. You create some early stage options, and then you manually modify those based on some of the factors you talked about. We have as software builders, we always have a trade-off between the degree of sophistication of the models and the ability to just quickly use them and quickly get to results. And we kind of have this 80-20 rule. So we have to do something which is going to yield the quickest, most usable results for the largest number of people. That's certainly the principle we apply in Carbon Designer 3D, for example.
Okay, we will finish on this question then. So from Chandu, will one-click LCA be proactively generating data points for generic LCA data sets in countries with lesser data availability?
The short answer, Chandu, is yes. And it's something we do at the moment. So we have a data team which has been designed to create generic data points to try and fill some of the many gaps that still exist. From a very practical point of view, if there are data points which need to be filling in your world, please let us know. You can get in touch at support at OneClick LCA and we'll hook you up with our data team, and there are options available there. But more generally speaking, we don't have the resource to create generic data sets everywhere, but we are always looking to expand the range of generics that we have because it benefits us. Obviously, it benefits our users as well. So, yes, if we can, is the short answer to your question.
Excellent. Thanks, Alex. Some really interesting questions there. And just as we finish up, I just want to draw everyone's attention to our next virtual event that's happening, our Summer Sustainability Summit. This is happening on the 5th of June, and I will drop the link into the chat now for anyone who wants to register. So we have 3 topic streams across 3 time zones. Lots of interesting guests. Do go and check out the landing page. You can see all the information there. And so right on time, all that's left for me to do is a huge thank you to everyone who's joined today, and a massive thank you to Alex as well. That was really interesting. We've had a huge number of people join today. So please do reach out to Alex, connect with him on LinkedIn, and we'll see you all again soon. Thank you.
Thanks, everyone.